Good evening, Algebra 1 class. We're continuing on in Chapter 2, and we're now in Section 2-7, and it's called Solving Proportions. We've been doing a lot of simple proportions in DMR, but we're going to work through some examples that are a little bit more complex now. So what I'd like for you to be able to do is read real-life problems and use proportions to solve them by the end of class. So we've talked about proportions many times already, but I'd still like to go ahead and define it one more time. A proportion is when two ratios, which are fractions, so I'll put that in parentheses, are equal. So this is going to be a big clue. You're going to know that you're working with a proportion when you have two fractions with an equal sign in between them. So here we have a property of proportions, and it says cross products of proportions are equal. You guys already know that. So the way we solve proportions basically what this is telling you is we need to cross multiply. That's basically what that's saying for you. So I'm going to box that in because that's pretty important. And we've been cross multiplying for a while, but it's still good to have a reminder. There we go. Okay. So with our first two examples in problem 1, you have seen stuff like this before in your DMR. So I take my terms and I cross multiply them. It doesn't matter what side you write the variable on, you're going to get the same answer either way. So I'm going to say 8 times m is 8m, and then 7 times 12 is 84. Now that I have my equation written out as one line, it's not, two fractions anymore, I can solve for the variable. So I'm going to divide by 8 and divide by 8, and I'm going to get a decimal for my answer. I'm going to get m is equal to 10.5. If you decided to write m is equal to 10.5, then that's okay as well. Or you might have written it as 3 over 2. Or no, sorry, not 3 over 2. It's going to be 21 over 2. Sorry about that. Okay, for the next one, we are going to cross multiply again. So now I'm going to put the 5x on the left side. I like to keep my variable on the left. If you don't want to do that, you don't have to, but that's just how I make mine work out. So I have 5x is equal to 7 times 4, which is 28. Now it's time to divide by 5 on either side. And I'm dividing by 5 because remember 5 right next to the variable means multiplication. So now I have x is equal to, if you turn it into a decimal, then it's going to be 5.6. Or if you turn it into a fraction or keep it as a fraction, it'll be 28 over 5. So both of these will work. Okay, now we're moving on to some examples that are going to be a little bit more complicated, but they shouldn't be too hard for you, as long as we remember what we need to. I've been saying it and preaching it from the mountaintops. The first thing I want you to know and recognize is you can put parentheses around these expressions. Why can you do that? Because I'm going to put a little star right here as a reminder. Remember, a fraction bar is a grouping symbol. Okay, so that's why we're allowed to put parentheses around these, because we know the fraction bar works as a grouping symbol. I am going to solve this the same way I do any other proportion. I'm going to cross multiply. But what I highly encourage you to do is to not do this in your head, because when people start doing distributive property in their head, they make mistakes and they forget to distribute all the way across. So what I want you to do is to write the terms out like they would be multiplied together. So I have 5 times f plus 3. So I'm going to write that out like 5 parentheses f plus 3. So I did one cross product. Now I'm doing the other. I'm going to go ahead and bring the 4 to the front, so this is going to equal 4 times f minus 8. Notice I'm keeping my parentheses. This is going to help you to not make a mistake with the distributive property if you write this step out. If you try to do the distributive property in your head, some might be able to do it without mistakes, but even I make mistakes, as you guys saw earlier in this note session. I accidentally said 10 over 5 was the wrong, or 10.5 was the wrong thing. So it's very easy to make mistakes when you're doing mental math, so I encourage you to write this step out. So now I have just a typical equation, and I am going to distribute the 5 and the 4 across their appropriate parentheses. So this gets me 5f plus 15 is equal to 4f minus 32. Okay, now I have an equation that has variables on both sides of the equal sign. So remember, like what we were discussing in previous classes, you can move whatever variable you want, but it'll be easier to move the smaller one. So I'm going to subtract 4f from both sides. When I do that, my 4's go away, and I'm left with f plus 15 is equal to negative 32. Now, to get rid of this plus 15, I'm going to subtract 15 from either side. And I get f is equal to negative 47. And I'm done. That's my answer. All right, let's work another one where we can kind of see that again. So go ahead and put parentheses around the top of that fraction. And then I'm going to draw in my arrows so I can cross multiply. So this is going to get me 5 times parentheses 2n plus 4 is equal to 6n. Okay, now I need to get rid of those parentheses, so I'm going to distribute. 5 times 2n is 10n, and 5 times 4 is 20. Okay, I have variables on both sides of my equal sign. So you have more than one way you can do this. I'm going to go ahead and move the smaller variable just so you can see this kind of in action when you don't have anything left on one side of the equation, just to give you a little bit of practice. So I'm going to minus 6n minus 6n. So 10 minus 6 is 4n, but these go away. But what do I write over here? Because I can't lose half of my equation. Well, 6n minus 6n is 0, so I can write that 0 in. So now I have 4n plus 20 is equal to 0. Now I want to move the 20, so I'm going to subtract it from either side. And I have 4n is equal to negative 20. Run out of space. Divide by 4 on either side, I'm barely going to make it. N is equal to negative 5. Right there at the very bottom of the page. Now, once again, you might have gotten to this answer in a slightly different way by maybe changing the order of these steps a little bit. That's okay. As long as you're performing legal math operations, that's all right. Okay, Now we have a couple word problems that I want to go through with you guys. We're going to set up proportions and then solve them just like any other problem. It says a portable media player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger media player has 80 gigabytes of storage. About how many songs can the larger media player hold? So when you have word problems that include or that involve proportions, you want to pay attention to what are the 2 variables that they're comparing. Because remember, a proportion is a pair of ratios. Ratios compare 2 quantities. So we are looking at gigabytes and songs. Those are the 2 things that we're comparing, gigabytes to songs. Now, it does not matter how you set up if you put songs on top and gigabytes on bottom. Doesn't matter. What does matter is whatever you choose, you keep it consistent. So here, if I'm going to keep everything as gigabytes over songs, let's set up my first ratio. It has 2 gigabytes and 500 songs. So I'm going to put 2 on top and 500 on the bottom because I decided that I'm going to put the gigabytes on the top of my fraction. Now I'm going to put in my equal sign. And then it says a similar but larger media player has 80 gigabytes of storage. Okay, this 80 is gigabytes. So I need to put it on the top of my other fraction as well. If you put it in the bottom, you're going to mess it up. You just have to stay consistent. So that is huge. Stay consistent. I'm going to highlight it. And put a giant explosion thing around it. That's how important this is. When setting up proportions, this whole problem could have been flipped upside down and you would have gotten the same answer. You just have to keep whatever you're putting on the top of your fractions consistent in both of your ratios. Okay, so now I'm trying to figure out how many songs the larger one can play. We don't know it, so I'm going to put S for songs. And now it's time to solve. So we cross multiply. We get 2S is equal to 20,000. I don't feel like that is right. I actually think it should be 40,000. Let me get my calculator and double check that. Yeah, I don't know why I had that as 20,000, but then I got paranoid, you guys. I thought maybe I'm doing my mental math wrong. So yeah, 2S is equal to 40,000. Sorry about that, you guys. Now, when I divide by 2 on either side, S is going to equal 20,000, or half of 40,000. And that's my answer. Okay. Let's hope that I get through this next problem without so many bumps and mistakes. It says it takes 4.5 cups of sugar to make 2 cakes. If Wendy wants to make 9 cakes, then how many cups of sugar will she need? So first we need to figure out what 2 things or what 2 variables are we comparing. We are comparing sugar to how many cakes we have. Or cups of sugar, I should say. So I'm going to say cups of sugar over cakes made. You could have made it cakes made over cups of sugar. This is just how I decided to set mine up. So now it says 4.5 cups of sugar to make 2 cakes. So that's my first ratio. 4.5 over 2 is equal to, and then it says she wants to make 9 cakes. How many cups of sugar will she need? Well, if cups of sugar is on top and that's what we're trying to figure out, I'm going to put in C for my variable and then 9 for my new amount of cakes. I'm going to cross multiply. So I get 2C is equal to 4.5 times 9 is going to get me 40.5. Okay, now I'm going to divide by 2 on either side, and I get C is equal to 20.25 cups of sugar. It sounds like a lot, but she is making 9 cakes after all. We have one more word problem, and hopefully you're catching on. We're just setting up our proportions based off of what our 2 variables are in the problem. So it says an 8-ounce can of orange juice contains 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in 12 ounces of orange juice? So now we're comparing ounces of juice to milligrams of vitamin C. So I'm going to say ounces of juice over milligrams of vitamin C. So this is just getting me organized. Now I can go back and reread my problem and set up my 2 proportions. It says 8 ounces of orange juice has 97 milligrams of vitamin C. So I have 8 over 97, and that needs to be set equal to something else. About how many milligrams of vitamin C are there in 12 ounces of orange juice? Okay, the 12 is going to go on the top of this fraction because remember I decided that ounces of juice is at the top of my fraction. So it's going to be 12 over my variable. Now it's time to cross multiply. So I have 8V is equal to 97 times 12 is 1,164. Now I'm going to divide by 8 on either side, and V is equal to 145.5 milligrams of vitamin C. And that's my answer. Alrighty, so that's it for our proportion practice today. Hopefully you were able to see how we can use proportions in real life pretty often, and we'll be practicing some more with this with a real life example soon in class. Until then, bye.